Salam sejahtera Malaysia. I'm bringing you the latest segment on one of the most devastating engineering tragedies in modern US infrastructure, the Big Dig Tunnel collapse. It was July 10, 2006 at around 11 p.m. when the Big Sudan was driving eastbound on Boston I-90 connected tunnel. Out of nowhere, approximately 24,000 pounds of suspended concrete panels came crashing down from the ceiling directly onto the vehicle. Tragically, 38-year-old Milena Delval was killed in the collapse. Her husband, Angel Delval, who was driving, injured but survived. This wasn't just an accident, it was a disaster rooted in a series of preventable failures. And today, we'll be taking a closer look into the root causes of this tragedy. From engineering design flaws to deeper ethical breaches that contributed to the collapse. What went wrong? Who was responsible? And how can we ensure such a tragedy never happens again? Stay with us as we explore the engineering missteps and ethical oversight behind the Big Dig Tunnel collapse.
Hello, I'm Sabrina. Today I'll be presenting on the 2006 Boston ceiling collapse, one of the most serious infrastructure failures in the US history. On July 10, 2006, large concrete panels in the I-90 tunnel fell onto a moving car, killing Milena Del Valle. The cause was epoxy-anchored bolts that degraded over time due to unsuitable for long-term overhead loads. This led to tunnel closures, major traffic disruption, and urgent inspections. Over 240 similar fixtures were found at risk, and costly repairs followed. Power Fasteners, the epoxy supplier, was charged with manslaughter. Massachusetts settled nearly $500 million with various contractors. This incident revealed that failures in material selection, oversight, and accountability prompts national tunnel reviews and stricter safety standards. It is a strong reminder that engineering ethics, especially public safety and integrity, must never be compromised. The events will be further discussed in following parts.
The first technical issue coming from epoxy anchor system failure when being used under sustained loading and causing 20 anchors to completely pull away during the collapse, with each anchor supporting over 4,600 pounds, which exceed the 500-pound design capacity. The next issue is the design flaw, where the engineering team made poor material choices despite understanding the epoxy limitations. They prioritized construction convenience over reliability by selecting epoxy with no pre-existing problems, while the tunnel lacked proper embedded channel. Then the critical warning signs were dismissed and not properly investigated. When anchor movement was first detected, engineers focused on installation issues rather than evaluating the fundamental material problems, allowing deterioration to progress unnoticed. Additionally, the environmental conditions like traffic, vibration, temperature changes, and moisture accelerates the deterioration. The quality control failure from communication gaps between teams create responsibility gaps, which led to a failure that cost $54 million to be repaired.
Thank you Muhammad Haji for his presentation. So I'm Justin and I will be presenting on the ethical reasons for failure. First, public safety was not prioritized in this project. Engineers used an adhesive that was never made for overhead and sustained load applications. This has put the tunnel users at risk. Second, warning signs from a 1999 failures in a similar tunnel sections were ignored. This shows a lack of diligence and good faith of engineers. Third, Power Fastener, the epoxy supplier, withheld key information about the adhesive limitation. This led to decisions based on misleading data. Finally, there was a conflict of interest. Pentel and Parsons Brinckerhoff served as both designer and construction managers in this project. This compromised transparency and independent judgment. So these ethical issues are believed to have indirectly led to this tragedy. So that's all from me. Thank you.
Based on a lesson from the tragic ceiling collapse, several recommendations can be proposed. Firstly, mandatory professional engineering supervision must be enforced throughout the design, construction, and maintenance phases of infrastructure project. Only registered professional engineers (PE) with a practicing certificate may submit engineering plans and supervise works. Secondly, there should be rigorous material specification reviews and quality assurance protocol, especially for structural components involving adhesive, fasteners, and suspension system. Third, routine independent inspection and audit system must be institutionalized. Engineers should support a transparent reporting culture where peer reviews and third-party audits are not seen as a challenge to authorities.
In conclusion, the Big Dig collapse in Boston serves as a reminder of how catastrophic failures in engineering are often associated with technical and ethical shortcomings. This case study highlighted the importance of comprehensive reform in how engineering should be supervised, audited, and managed to prevent similar incidents from occurring.